we're ready to get started here with the presentation from CatzPaw. Russell, would you introduce the program, please?
Yeah, thanks, Ron. So once again, for the from Zoom, that we're happy to have Sherry Johnson from Locust Grove, Georgia, which is just a little bit outside Hotlanta there. So I think this is going to be a real neat presentation with their CatzPaw company there. So Sherry, welcome and take it away.
Okay, great. All right. Thank you, everybody, for attending. As he said, I'm Sherry, and I will be presenting. And basically, we are a small two-person company located just outside of Hotlanta. And today it's definitely hot and muggy. I've been working with computers for longer than I like to think, and with 3D printing for over 10 years now. We basically do everything in-house. We design it, 3D print it, package it, ship it, and get it out the door to our customers. Things that we print, and pretty much this covers things that other people print too, because we're not the only group out there or the only company that does 3D printing. But these are some of the things that we print specifically. Scenic details, you name it. If you find it in a scene somewhere, we print it or we can print it. Animals, birds, people, figures that aren't people like Bigfoot, which you see there. We do buildings, vehicles. Down there in the corner is our little Russell Wing snowplow, which is actually based on a caboose. So I feel sad that we missed your caboose entry, because I think our snowplow would have done really good there. We also, because my background is electrical engineering, I had to light things. So we also have products that flicker, our burn barrels, barbecue grills, campfires. We have lit several things, gas pumps, our buildings. We have flashing traffic barrels. Our UFO has flashing lights. And something that we are working on, which is almost complete and getting ready for our beta testers, is our Invisitrax system. I don't know if any of y'all have ever seen the Magna Rail system, which is in Europe, but this is going to be an equivalent where you can make figures, cars, people move without anybody seeing what's going on. And this system came about because as soon as we did Bigfoot, we had customers that said Bigfoot needs to walk through the woods. So for the last 9 years, we've been trying to figure out how to make Bigfoot walk through the woods. And we finally have a solution. So keep an eye out. That will be coming probably towards the end of the year. Where you find things that are 3D printed, of course, on model railroad layouts, farm toy displays, which is our second largest group, slot car layouts, which is how we actually got started in this business, was I did slot cars and I needed stuff to sit around my layout. Folks that do die-cast dioramas, they are the ones that take like Hot Wheels and Matchbox cars or 18-wheeler trucks and just do little specific dioramas geared to their products or their particular interest. Historical dioramas, and I should change that to historical dioramas and museums, which you're going to see shortly. School projects, we get a lot of folks who are like, oh, my son needs to come up with a country western or a western style campfire because we're doing this report and he needs to do a diorama. Can you do this? We can do that. Pretty much any place you want a scale model or need a scale model, that's where you will find our 3D printed products and others' 3D printed products. Another example, this little stop motion video that Tom Barker did. He used our figures. This is from way back. This is actually from 9 years ago, and he used that for a video. We have a shot here from Pete Silcox, our flickering campfire. It's a static one, so you don't see it flicker. We've got our moonshine setup, our cow and calf pair there that actually helped Christopher win $10,000 at their convention for a contest. Our latest thing that we have done is this museum project, which is in Arizona. And this is actually a 1/32 scale where we did the figures and the animals. And if you're ever in Fountain Hills, Arizona, check out the little display there in that museum. Another one that we actually got us started in this glorious realm is the Cuthbert Historical Project. They were one of our first customers. They found us at our first train show, and Mr. Bradley kept walking by the table and he wasn't sure. We had stuff, but it wasn't quite what he needed. And my partner, Yolanda, stopped him and she said, well, what do you need? And he described what he needed, all these HO scale figures and specialty items to go on this display. And of course, my partner, who's the sales and marketing person, said, yes, we can do that, no problem. As I'm shaking my head, no, but it all worked out in the end. We started with just making 50 products for this project, and we wound up making over 450 items for this project. And next up is going to be a short video from Mr. Bradley, talking about how being able to get these products and how models and scale models are so important in preserving history.
My name is Jimmy Bradley. I'm on the Board of County Commissioners here and worked with the commissioners to do the work restoring this building. Very active with HO model trains. And when we were working on the restoration of this building, the issue of the trains came about because of transportation. We started looking for some ideas as to what could we do that would emphasize how transportation fit into the growth of Randolph County about that time. We picked the time period because of the use of the trains to bring the injured in here right at the end of the Civil War. The first thing we did when we got started was to try to get in your mind what Cuthbert looked like and how things happened and what was going on. They started the journey into town from the railroad station, and we tried to depict the things that they might have seen. For instance, there's a carriage there. The carriage is still existent today. It has been restored. It's in a museum, but it was used to meet every train to carry at least one person around one of the hospitals. We depicted where they went by the old courthouse that used to be in the middle of the square. We tried to depict the businesses as best we could that they look like in the names. Some of the buildings are still there. Is the lawyers' offices that are right across the road from us here. Methodist Church is right across the street over here. These buildings are still here. Near about everything on there is to scale, but handmade to look like the things that were there. I made a trip to a train show in Atlanta and I ran into two ladies there. They run CatzPaw LLC, and they were selling figures. None of them were anything like I wanted. And one of the ladies said, well, we can make you anything you want. So my wife and I made a trip up to Locust Grove where they live and watched them make them. But I stood there and told her how I wanted the soldier to look with his leg blown off or his arm blown off or whatever. Roughly 400 figures that are on that diorama. We described what we wanted them to look like, including the wagons, the people. Tried to make it just as realistic as it was during that time period. Conservation is not preservation, but you still want people to be able to relate to how things work. And sometimes the only way in this visual, a picture, but something like we did there. And that's why the people were so important to understand the horrible suffering that went on, and then the great gift that people in Cuthbert gave to try to help.
I highly recommend if you're ever down in Southwest Georgia to stop by there. The actual display, and if you go to our website, we have a link that has more in depth on that, but the display is amazing. And Mr. Jimmy doesn't take enough credit because he scratch built every one of the buildings that's on that layout. It is just, it's amazing. Some of the benefits of 3D printing, well, first off, you can get custom products and stuff, but you can pretty much, you have all sorts of unique products that are coming available. Things before that were out of the question to design or get manufactured are now becoming available. Somebody asks for it, you can sit down at the computer, design it, and print it. Custom items. We have here Charlotte and Brooklyn and Savannah. Those are our grandbabies. Each year I design Christmas ornaments for them and send them off to them. We do a lot of custom work, the Cuthbert job, the Arizona job. The gentleman there cutting meat was actually one that I did of my dad in honor of him because he was a journeyman meat cutter when he was younger. You can also create or replace parts for things that are no longer manufactured. We work with one of the companies here in Georgia that repairs a lot of Lionel things, and you just can't get the parts anymore. They don't make them, and they'll send us the broken part and what it goes into, and they'll say, hey, you know, we need this. Can you do this for us? And sure enough, we sit down, we draw it, we get it working, get those old things fixed that you couldn't fix before. It's also great for doing prototypes because you can do the drawing, you can prototype it, you can print it, see where you've got a problem, go back, make changes, print it again, without having to go out and spend several $1,000s on talking to someone to get it manufactured and molds made and so forth. It's also scalable. We usually start everything in 1/64th scale because that's our slot cars. That's where we got our start, and it's kind of in the middle. And if we design something for 1/64 scale, we can resize it up or down and print it in the other sizes. We've gone as small as Z scale, which these chairs only go to N. I couldn't do one in Z. Z is beyond chair quality, but we can do buildings. And we can go up to any size, because once it's drawn, if you need an off size, we can scale to that as well. It's just a matter of adjusting the actual file to print and then printing it. It has unlimited creativity, so to speak. They say if it can be drawn on the computer, it can be 3D printed. That's true, but you have to take into some design requirements to make that happen. As I mentioned, sort of, it's toolless, which means you don't have to go out and have molds made or dies done or any specific setup tools required. You can just design it and print it. For things that are complex, you can print them in multiple pieces and assemble it if you need to. There is an array of materials available for all different types of printers. I'm going to discuss the types of printers in just a moment. But the different materials that are available, you can get flexible materials, you can get carbon infused filaments or materials that make things really hard. You can get filaments that will let you actually do casting in metal if you want to burn them out. There are resins, the same thing, for strength, durability, flexibility. So you can go through and say, okay, I need this to be flexible. So I'm going to pick a flexible resin or flexible filament. We use those when we print the tires for our vehicles. For our buildings, we want them to be hard and firm and not warped. So we pick a harder, more sturdy material to print those in. The technology that goes into 3D printing. Well, we mentioned that it is an additive process. And what that means is in 3D printing, no matter what type of 3D printer it is, an object is built by placing one layer on top of another layer. The types of printers out there, the fused deposition modeling, or FDM, and it's also referred to as FFM, uses filament, comes in a big old spool, actually looks like weed eater string. Except you can get it a lot more materials and a lot different colors. Those types of printers can usually print at 0.2 millimeters. You can go as low as a layer thickness of 0.1 millimeter. And the average cost for a good system is between $200 and $3,000. Your resin printers or your digital light projection printers give you much, much finer layer heights, 0.01 millimeter versus 0.1 millimeter. They can go down as low as 0.05. It's just amazing. These printers on average cost $200 to $2,000. Within the last year to 2 years, the prices on all these printers have dropped. When we first started, 8 years ago, we paid $3,000 for our first filament printer. I just purchased a new one that prints really big, and we spent $300 on it. So as the technology has gotten better, the prices have dropped. On the high end, we have all sorts of different printers that places like Shapeways and other 3D print services use. The Material Jet, the PolyJet, stereolithography. Those printers start at roughly $45,000 and go up, which is why Yolanda won't let me have one of those. The filament-based printers that we use, we have a total of 5 of these now that are in the house, the dining room, former dining room, and the garage has been converted. Most of them have dual print heads so that we can print in 2 different colors or 2 different materials at a time. Our latest one, which is pictured here at the bottom, the Anycubic Chiron, which has a roughly 16-inch build area versus the old printers in the old days that couldn't go that big, that had a 9 by 6-inch build area. So as the technology has progressed, so has the size that you can print. Same as we have the different filaments that we mentioned. I like to print in ABS plastic. That's the same thing that a Lego building block is made out of, so that I know that it's durable. You can get ABS plastic in lots of different colors. Other filaments that we use are PLA, HIPS. HIPS is kind of cool. It dissolves in limonene. So if I'm printing something really complex, I can use that for a support material. Because if you print something, you can't print in midair. You have to have a support underneath it. And with the HIPS, it dissolves away. There are nylon, as I mentioned, carbon infused. There are literally hundreds and hundreds of different types of filaments out there. We source our filament from a US-based company, most notably 3D X-Tech. We try and stay away from the Chinese imports. We found that quality can vary with them, and with COVID, lead times trying to get anything from them has just been insane. How the printer actually works, how the FDM printer works. You have your filament spool. It goes through a little 2 wheels stepper motor extruder that kind of pulls the filament in, pushes it down, pushes it into a heated nozzle that melts the filament, doesn't melt it to a liquid, but it gets it really, really soft. And then that filament comes out and it's put down layer by layer onto the build plate. A lot of times the print head or that nozzle moves back and forth on an XY plane, and the build plate goes up and down, or it goes down each layer as you print. It's really fun to watch, which is why I have a nice little time-lapse video coming up showing how it actually works. Now, in reality, that took 2.5 hours to print, and it used 21 grams of filament. The print time is based on how tall the object is, how big around it is, the layer height that you use, and the number of layers. So in this particular instance, we use 0.2 millimeters for the layer height. Since the object was a little over 59 millimeters tall, it took 298 layers of stacked filament to make that particular object. Next up are the resin-based printers, which we now have 5 of those too. We have 4 of the smaller ones where resin really started with the small build area because it's very tricky to print with. And the small printers could only print roughly 4 by 2 inches. The new larger one that we have can actually print 7.5 by 4 inches. There are some others out there that are that can print larger than that, but they are a lot more expensive. Those come back to that $20,000, $30,000 range. We use various different resins depending upon what we're actually printing. For our figures, we use Hero Tough, which keeps a little flex to it. So when you drop them, their little arms and legs don't break off. We can get it in colors. They also have a pigment kit where you can make your own colors. We have the standard fast and hard resins, which are the ones that we use for buildings because we need those to be firm, and also for our snowplow and our bus. For mechanical parts, for like gears, which are going to be in our Invisitrax product, we use an engineering resin, which is designed for interlocking parts. For tires, we use a gasket resin because we want things to be flexible. Again, we source from a US-based company, 3D Resin Solutions. They're great. They're actually located up in Indiana. One of these days, I want to go visit them. And just little pictures of their bottles there. How the resin printing works. Unlike the filament where you melt things, this uses a UV light to cure the resin. You have a liquid vat that has a clear bottom that you put the resin in. Your software has created an individual slice, so it creates a mask, and it masks so that the UV light only cures just the resin that makes up your object. In theory, when the print works right, that sticks to the build platform, and that platform goes up and down, in and out of the resin vat as it cures, and it builds your object. And to show that one in the works, we have another little time-lapse video. And you can see in the description of that, it's also a little taller than the other, but this took almost 8 hours to print. Again, the print time is based on how large or how tall the object is, the layer height used, which in this case was 0.05 millimeters. And this had a total layer count of 2,418, considerably more layers than the other print. For the heck of it, we did that vase in the resin printer and compared it. In the resin printer, it took almost 4 hours, so still longer than the FDM print. And it had 1,172 layers versus the 298. So you can see you get much better resolution with those teeny tiny layer heights. And for the fun of it, and we love this, the 3D pen. We use this a lot for repairs. It's like the FDM printer, except it uses filament. You could kind of think of it as a hot glue gun on steroids. Basically, the filament goes in one end. It has a little button that you push to push the filament through the heated nozzle. And then wherever you're waving the nozzle end is where the filament is going to come out or be placed. It cools really quickly, so you have to work with it. And we're going to show you a video here. This video is not something that we have done because I am not this talented with the pen. Pretty much use the 3D pen for filling in large holes and cracks on things that I printed that I need to repair, because like I said, I am not that talented. I wish I were, but I'm not. Comparing the two types of printers, what they're good for and best used for. FDM printers are good if you're printing something really, really large. You need it lightweight. You need it accuracy, the dimensions pretty accurate. Doesn't have a lot of detail. Whereas the resin printer gives you high resolution, a lot of detail, but resin is heavy. Sometimes working with the different resins, you have to make sure you pick a resin that is stable in order to get dimensions that are accurate. Both are pretty easy to use, but the resin printer has more of a cleanup process than the FDM printer does. Material costs are actually about the same. I haven't really noticed a difference when I print from one thing to the other. Both require temperature regulated environments, humidity control. That humidity can mess with filament, it can mess with the prints while you're printing. Even with my printers in an enclosed environment, I try not to print on a rainy day because it just has more problems. Both require ventilation. Both can give off fumes as they print. One with the heated resin. With the filament, you're actually, since it's melting plastic, the little VOCs can get into the air. So you definitely want to keep those vented and get those outside. In addition, with the resin printer, since it uses a UV light to cure, you need to make sure that UV light is blocked from your room. So out in the garage, I've got all the windows covered where the UV resin or where the resin printers are, so that UV light can't get in there. Both printers, you're going to need tools for removing supports. With the resin, you also need a washing station where you can remove the excess uncured resin, and a curing station because you have to cure a second time or a final cure on your resin prints to actually set the final or the outside layers of that print. You know, pros used to be that the FDM printers were cheaper. That's not true anymore. They're low cost, large build area. The pros for the resin printer, great detail, smooth surfaces, extra time to clean up. The cons on your FDM are the rough surface. You actually see the layer lines, which there are some cleanup or post-processing techniques that you can use to get rid of those, like sandpaper, which takes a lot of time. When comparing the prints here, you can see on the FDM compared to the resin, here's this nice little ratchet gear but you can actually see how rough it is compared to the resin print. Same thing with this little manifold piece. You can see the layers and versus how smooth the other parts are. Same with our little Groot over here. You can see how smooth the resin print is versus the layer lines and so forth with the FDM print. People have always asked, how much does it cost to print something? Can you quote me what it costs to print something? And we see a lot of people that come back and say, okay, well, you know, it's only going to cost me 20 cents in material because it's only using 5, grams. Well, unfortunately, the cost of actually printing something on a 3D printer is a little more than just the cost of the material. You do have the material cost itself, whether it be the resin or the filament, but there are also consumables that you use, material items, such as gloves when you're working with a resin printer, rags, masks. With the FDM printers, with the ABS, I use acetone, isopropyl alcohol for the cleanup, Kapton tape. All these things get used each time a print is done and needs to be calculated in when you're doing your cost of what a print is. You also have to put in manpower costs. It takes time to set up the printer, get it out there, set it up, clean it, the actual printing operation time, and then also the post-processing time. The upkeep costs of a 3D printer. It would be nice if everything lasted forever, but it doesn't. We have to replace belts and nozzles and vats and screens and build platforms. It also takes electricity to run that printer, which we all know electricity is not free. Then if you're going to do any post-processing, that too takes time and tools and materials. All these things factor in when you're actually doing the true cost of creating a 3D print. Print times are based on, as we discussed earlier, the height of a model. For FDM printers, also the travel distance, how far it's got to go around that build plate. Resin printers don't have to worry about that. You just have to worry about each layer. People complain a lot about Shapeways and the other 3D print services, why their prints are so expensive, but they actually have a lot of overhead because they're going to have even more overhead. They're going to have salaries and buildings and so forth. But typically, Shapeways bases their prices on material selected, the finish you selected, which dictates the post-processing, the volume of the model or how much material is used. For them, machine space, because they gang a lot of stuff together, supports the parts bounds value, or what is the overall outside square that all the parts have to fit into, how many you're getting done, and as I mentioned, the post-processing. How it's done from concept to print. First, we get an idea, or more likely, we get a request. So we get inspiration, somebody wants something. Next, we do research. We try and get as many measurements, drawings, photographs as possible of the item that we're trying to create. We try to make sure that all of our items are true to scale and as realistic as possible. And we have customers that get out their calipers and measure to let us know whether or not we have met that accuracy. During this stage, we also check to see if we are going to be infringing on anyone else's copyrights or trademarks. You will find that we don't do a lot of cars, but the only car we offer is the Tucker, because Tucker said we could. Ford and the rest of these, you have to deal with their licensing and copyrights. And with a lot of vehicles, you also have to deal with the companies like Mattel and Hot Wheels who have purchased the right to produce those vehicles. Same with Greenlight. That's also why when you see our products, you will see them say that they are based on something, like our Igloo cooler. Our round cooler is based on an Igloo cooler, but it's not an Igloo cooler. Third, we take all those original drawings, get out the calculator, and we scale it to, in our case, 1/64 scale or S, and do the scale drawings. So we convert the full size, get it down to what we really need it to be, in order to start creating the 3D item, which is next up. We actually go to our CAD program, and we'll discuss those shortly, and we start creating the actual 3D object. During this phase, you also want to take into account if you're going to be printing it in multiple colors, if it's going to be printed in multiple pieces. And here we show that we are doing our little phone booth, our little phone kiosk, which if there's any young folk here, I apologize, you probably don't have a clue what this is. But here we do the phone kiosk and we break it into multiple parts so that we can print it in black and in the blue, and then we assemble it once it's printed. Next up, once we have it drawn, we have to convert it to a format that our printer software can understand, which right now the standard is an STL file. Basically, it's a fancy name for standard tessellation language, and which is a fancy name for saying all we deal with is the shape of the object. We don't care about the color. We don't care about anything else. We just care about the dimensions and the shape of this object. Where the CAD file shows the different colors, the STL file says, nope, I just need to know the shapes. Because that's all your printer cares about, is the shape. Next, we have to make sure that it is printable. It might look good on the screen, but it may not necessarily print. And this is true even if you download something from the internet that says it's 3D printable. Your printer has to have an object that is watertight, which means no holes. If you have this beautiful drawing and there's a hole in it, it's not going to print that, which means you're going to get an error. It needs to be all one piece. When you're printing something, you saw the little thing is spinning around, or it's doing the resin, and it doesn't know what to do if the pieces are two parts. It says, there's a gap here. I'm not sure what I'm doing, so I might print it, I might not print it. Everything needs to be one piece. It needs to be manifold. This is one of those things that's hard to describe. So you can kind of see here with the picture that those little triangles that make up an image can only touch on two sides or two faces, two edges. You can't have more than one. And because an STL file is made up of all these little triangles or polygons, they also need to be facing forward. Or sometimes some of the software that creates, or when you draw a file, puts them on there backwards. It doesn't know front from back. SketchUp is notorious for this because SketchUp was designed to draw things in 2D. So when you convert it to 3D, sometimes the little things come out forward, sometimes they come up backwards, sometimes they're manifold, sometimes they're not. Fortunately, there are several programs out there and plugins that you can use to fix these problems, because you're not going to be able to see them with the naked eye. Mesh Mixer is a great free program, and you can import your file in there. And as you can see here in this image, it points out different problems with this file. It lets me know that I've got some holes and some gaps that need to get filled. It fixes minor things. Another application, or actually this is an online site, Make Printable, that we use, does a much more detailed repair. If you look here, it says I've got 142 non-manifold edges. Gee, the picture looked perfect. It also says I've got 4 shells. You know, I thought I only had 1, but it says I've got 4. So I run and have Mesh Mixer, Make Printable, or other repair software fix the file, make it so that it can be printed. And then we take that fixed file and we bring it into a piece of software that slices the file, or actually takes that image and creates all the little individual layers that make up the file. For us, on the filament printers, we do the 0.2 millimeter layer thickness. For resin, we do the 0.05 millimeter thickness. So remember, the greater the detail, the thinner the layer, the longer it's going to take to print. Something else the slicing software does is add supports. I mentioned earlier that you can't print in midair. unless you're using the 3D printing pin. If you're, for the other printers, you have to have something, some structure for the filament or the resin to stick to. So you have to add supports, which get removed in post-processing. Once all of this is done, and you can kind of see here in this little time lapse, you can check to see how your print is going to do, because you can simulate how each layer is going to print. I usually do this before I print everything, because sometimes, even though I fixed it, I come in here and it starts doing something and I get little red marks or little yellow marks, which lets me know I need to repair it again, that I missed something. Once the file is sliced and it's created in the code for each machine, needs to say the filament one uses a different one than the resin, we print it. And we keep our fingers crossed, because usually the first time we print something, we get this. Never expect a perfect print the first time around. It is very, very rare. On the resin side, we get things that look like this, and you wonder what the heck happened there. Well, since we're not sure what the heck happened there, we go back, we check our printer, make sure there's no mechanical issues with the printer. Before we start screwing around with the file, we make sure that the printer is fine. Do normal maintenance, re-level or trim the build plate, check our cables, remix our resin. Having really good mixed resin is key for resin printing. For filament, making sure our filament is dry. That is critical. Once we check all that stuff, if it all looked good, then we go back to the original file, we tweak it, because we might look at it and go, oh, you know what? It would have printed better if I'd separate it into two pieces. Or it would have printed better if I put an angle here instead of let it be straight. Then we go back, we export it, we convert it to the STL file, repair that, adjust any supports, because we might have noticed that some areas looked good, some didn't. So we might add some supports, slice the file, and print it again. And we repeat this until we actually get a successful print. Now, for those who are just printing at home, you can stop there, because once you got one thing, you're happy because you're good. You can go with it. Since we sell our prints, we do this at least 5 times, because we have found just because it prints the first time doesn't mean it will print for a second or a third time successfully. Usually, if we get it 5 times, we know that we've worked out the bugs, we've got the printers done right, the resin's right, the design is correct. Post-processing. Because there's more to printing than just printing, you have to work on it afterwards. As I mentioned with the resin printers, you have to clean any of the uncured liquid resin off. It got pulled up out of that vat of liquid and it's still dripping liquid. So you have to get that off of there. There are wash and cure stations that will wash the print, or you can just get like a sonic cleaner, which is what I use, and put your print in a container with some isopropyl alcohol, put it in the sonic cleaner for a couple minutes, and it will get all that loose resin off of it. For curing, the wash and cure station does both. So once it's got all the resin off, it will also cure your print, that final step, with UV lights. Or you can actually go ahead and purchase little UV lights separately so that you can wash and cure separate, which is what we do, because we print really big stuff and really small stuff, and some stuff just wouldn't fit in the wash and cure station. So we needed to be more flexible. Both types of printers, as I mentioned, require supports which need to be removed. And here you can see some prints that have supports. One of our figures printed there where we printed a bunch at a time. One of our weather vanes where you can see after the supports are removed versus with the supports. These can be done, supports can be removed with diagonal cutters. They can be removed with X-Acto knives, scalpels, anything that's sharp. For resin printers, this doesn't work on filament. You can actually heat the print with, say, a hot air gun or a blow dryer. Some people actually put their prints in warm water, which, unless you know the absorption rate of your resin, I caution. And once those supports are warm, they are more flexible and you can pop them loose much easier from your print. That only works if your supports are bigger than your prints. Like on this weather vane, I wouldn't do that because, as you can see, that little arrow and the pole that it sits on is very thin. It's about the same thickness as my supports, which means if I tried to use the heat on it, I would probably break those in the process. So I had to remove all the supports here using, I probably actually used the scalpel for that. Other things to take a look at, and usually with resin, you don't really need to sand as much as you do as with your filament printers. But with filament, a lot of times you're going to want to sand the layer lines or smooth it. Filling gaps, sometimes there's warping and you need to fill gaps in. You can use the 3D printing pen if they're large, which is what we use. One of the other reasons we use ABS filament is we can dissolve that in acetone and fill cracks with that. And with the resin, we can use the liquid resin, drop it into place, and use a UV flashlight to cure. For cutting, again, sprue cutters, diagonal cutters, hobby knives, scalpels, jeweler saws, hot knives are great. Sanding, we've got the trusty Dremel sanding blocks. One tool that I love in particular is this micro sander from Micromart. Instead of it using a rotary head, because I found when I sand with that, a lot of times I get little dips in my prints. This oscillates back and forth and sands flat. So this is really good if you need to sand your surface and make sure it's flat. You can also smooth things with heat using a hot knife, or you could use a soldering iron. There's this other little tool that we purchased, a 3D printing finishing tool that has all these different print heads, so we can actually melt in little round spots or flat spots or cut things. Of course, a UV flashlight if we're working with our resin prints. You can put down a layer of thin resin on a bump and again, cure that to smooth out areas. I've actually used resin on a filament print to fill in the gaps, and it came up with a really neat finish. So experiment. We also mentioned that we print things in parts. So you want to be able to assemble those parts. You want to be able to glue them together. Super glue is always a go-to. Some super glues work better than others. Some super glues will also distort the different filaments and the different resins. So before you use any of those glue on your final project, print some test parts or on your scraps and test those glues on there first. Again, you can also use resin to glue things together, or again, the ABS slurry, which is your ABS in acetone. Painting, people ask about painting 3D prints. We recommend using acrylic-based paints, especially if you're getting something from Shapeways, because the acrylic-based paints won't interact with anything. Enamel paints, depending upon what chemicals they have in them, can interact with different resins and different filaments. So again, if you're going to use an enamel, test it on some scrap. You can use everything from your expensive paints, your army painters, all the way down to the 50-cent bottles that you can get at Walmart. They work great. If you're going to handle your object a lot, we recommend sealing it with a top coat, just because paint wears, and that's true no matter what paint you have. My big thing is on my people, I notice if I don't seal them, I have a tendency to wear the paint off the toes of their shoes. So I have to go back and touch them up. The software used and some useful links, all the little software that we use to make this happen. For mechanical designs, such as buildings, objects like gas pumps, anything that's more mechanical in nature or solid or rigid. Tinkercad, which is free. It's an online. Everybody says, oh, it's too simple because you just build things with shapes. It is simple, but it offers a lot of features. Easy to use is number one. It has a great little option where once you get it started in Tinkercad, you can send it directly to Fusion 360, which is a higher end CAD software, which can actually, it's really high end. It has a lot of features. It can also run a CNC machine, and it has a high learning curve, but you can go from one to the other easily. Blender is another free option, which I have Blender. I open Blender, I get frustrated with Blender and I close it. If you've used Blender and you've learned how to use it as your software, it is marvelous. It just has a high learning curve. One day I plan on really learning how to use Blender. It's just I'm always in such a rush, I never get the chance. For more organic designs, such as people and animals, we use DAZ 3D, which is great. It's a free program with in-app purchases. You can buy different bodies, different body shapes, different animal shapes, clothing, and so forth. It will let you do different poses. It's our go-to for creating animals and figures. ZBrush, which is like modeling with clay, love this. A lot of times I will start something in DAZ, export it, and bring it into ZBrush for extra detailing that I can't do in the other program. And again, Blender falls in here because Blender can do hard modeling, it can do soft modeling. It's very, very versatile. You just have to learn how to use it. Other design software that's out there, and there are many, many more: SketchUp, Rhino, FreeCAD, MakeHuman is another one that is free for making people. Sculpt GL is a free version of ZBrush, which is an online based program. Again, if you're just getting into this, download all the trials, open them up, play with them, see which one looks like it's going to be the one that you're going to be willing to spend the time to learn how to use. Modifying and repairing. We saw that I use Mesh Mixer to look for errors. It can also do basic modeling as well. Before I do anything, once I bring a person or an animal from DAZ, I bring it into Mesh Mixer, look for errors. And in here, I can go in and like make the eyeballs bigger or make buttons bigger, accentuate all those little details that might get lost. Because sometimes when you're working with small details, you have to exaggerate them in order to get them to print properly. MeshLab pretty much does the same thing. It just has a lot more features and options and another higher learning curve. NetFab, which I went to use it recently and it's no longer available. We found that Autodesk has merged it with Fusion. So I'm going to need to, on my next version of this presentation, pull that out of there. But if you're using Fusion 360, you can also repair your models within there. Make Printable, which we saw earlier, was the one that showed all the problems that I have. It's an online service and you can pay to have each model repaired, or you can do a monthly subscription, or you can do an annual subscription. Because we do so many designs, we opted for the annual subscription. Slicing. As we mentioned, you've got to take that STL and you got to break it down into the individual layers for the printer to print. For filament printers, Cura 3D has become the industry standard go-to. It supports more than just the Utilimate printers. It supports a host. They just came out with a brand new version that has a lot of features. I have like 50 options shown for me to change different and tweak things. They have over 500 different things that you can change and tweak to make your print better. Simplify 3D used to be the go-to, which is paid for. Cura is free. It too is another excellent slicing software. And Prusa Slicer, it too can support more than just the Prusa printers. And it is also a free software. The great thing about the Prussia is besides being able to slice for filament printers, it can also slice for resin printers. It's the only one that can do that. For slicing in resin, Chitubox right now is the leader, followed closely by Lychee. They both have free versions, and they also have professional versions. The free version standard user works fine for the things that we're using. Again, this is where you can set your layer heights, set your exposure, lift and retraction. There are just so many settings that could be a whole other presentation, settings for resin and settings for filament printers. On the resin side, there's another tool called UV Tools, which is used because it needs one more final repair step. Once you have your item sliced, you need to go through and make sure with a resin printer that there are no islands or any little parts that are missing or any suction cups or resin traps. And UV Tools will look for those and repair those issues that might arise with your file. Other slicers that are on the market that are out there, Octoprint is a good one. It actually has versions for resin and for filament. And it's really cool because it will let you hook up a camera and actually monitor your printers remotely for remote control. Matter Control is a new one that's on the market, and it actually will let you slice, but it will actually let you create models, draw models, repair models. It's supposed to be a one-stop shop for everything. I've downloaded it, but I haven't used it yet, but I wanted to include it in this presentation as an option. All right, so you bought a resin printer or filament printer and you can't draw. You're trying, you're learning. Well, there are tons of sites out there where you can download things. And even if you can draw, there's no point in recreating the wheel. So you might want to go to one of these sites and see if somebody's already created something that you're looking for. Especially with like train engines and train cars and trucks and things like that. A lot of people have already created like that, so you don't have to recreate it if you want to print it. Thingiverse is the #1. Models there are free. Cults has a mixture of mixed and free. My Mini Factory, those are basically the top 3. Shapeways, you can go there and some of the artists will actually let you download the files and print them yourself. Most of the time with Shapeways, you have to actually have Shapeways print the object. If you do fantasy figures, these aren't good for like real people, but if you're like into Dungeons and Dragons and other role-playing games, Hero Forge and Titancraft will let you create dragons and wizards and those type of figures and download them. As I mentioned before, even though you're downloading these files and the people that created them say that they're printable, run them through your repair utility because they may not be. Can I sell prints of the files of things I've downloaded? No. Most everybody shares everything on the premise that you're going to print it and use it for yourself, not to sell it. There are exceptions to that, where you can have a Creative Commons license that says commercial use allowed. If it states that, then you can download that model, print it, and sell the prints. You cannot sell the STL file, but you can sell prints of that file. When in doubt, contact the creator of the file and ask them whether or not you can sell the prints. Okay, I don't have a printer, but I've been designing stuff for a while. What can I do in this case? Well, there are several 3D printing service providers out there. Shapeways is #1. It has offices in the US and Europe. iMaterialize and Sculptio are both based in Europe. Not sure where Exometry is located, and Hubs is more of a facility that puts you in contact with people who can print for you. Even though you have a printer, you might decide, and you're just using it to create prototype prints, when you want something finished, you wanted it printed in brass or a different material, something that you can't print in, this would also be a good indication or a good time to use one of these 3D service providers. Also, check with your local library, schools, if you have a makerspace in your area. A lot of those places now have 3D printers where you can go in and the public can use them. Some are free, some of them you have to bring your own material, some they charge you by the hour, some of them just charge you for the material. Where can I learn more? Because we've covered a lot in this presentation and we just hit on the highlights. For designing, the 3D printing handbook is great. I have a copy of this. I keep getting the new revisions. It talks about the technologies. If you're designing for your home printer, if you're designing for those wonderful $40,000 printers, it talks about things to take into consideration, orientation, spaces, gaps you need if you're doing interlocking parts. It gives you a lot of technical information for doing your design and for which material you're designing for. Same thing with functional design for 3D printing. Again, it talks about the weaknesses. You know, on the filament printers, if you're printing layer by layer, those layer lines that are just, you know, heated are weak areas. So if you're going to be printing something and you need it for strength, you need to orient your part for that. Or you need to allow for maybe a metal rod to be inserted. So this is good for functional design, for getting you in there, knowing how to create and draw so that your prints will not break and be functional. 3D printing failures. As you've seen, I have had failures, many, many failures. Some are not as dramatic as that. Some might just be little blobbles or air gaps, or they might have a warp here or a little problem there, and you don't know what to do. This book has photos of the most common failures and things to look at, like, oh, you need to dry your filament. Oh, you need to change your retraction speed. It's an excellent resource for troubleshooting problems with your prints. Before you do any type of printing on either machine, always look for the technical data sheets and the safety data sheets. These are critical. You need to know the materials that you are printing with. For example, even on the filament side, there was a wonderful filament that I wanted to download and print with. It was a Delrin. It was going to be nice and smooth because I'm trying to print parts that slide on each other. I pulled the technical data sheet, pulled the safety data sheet, and found out that when it's heated to print, it gives off formaldehyde fumes. Gives off formaldehyde in the air. Okay, I have ventilation, but my ventilation system is not set up to deal with formaldehyde. I am not printing with that material. So be aware of the materials that you are using, because they can be, the resins, if you get them on your skin, can cause irritants. Some people have inhaled irritants. Be sure to look at these sheets because they will tell you what to look for, environmental things you need to do for successful prints with these materials. And if you have a material that you just purchased and you can't find a material data sheet, I would recommend not using it. I just wouldn't feel safe not knowing what is in that product and having it in my house giving off fumes and VOCs. Okay, a couple of frequently asked questions. Can I make my own resin? No. Unless you're a chemist, you have a lab, you have a clean room, and you know how to take all the proper precautions. Can I make my own filament? You could. There are actually, and I looked into this because there's a lot of waste material that it's like, oh, if I could just cut that up and melt it back down and melt it back into filament, that would be awesome. Well, here is a short little video that shows why you probably aren't going to want to try that. So in practice, it would be really cool, but in order to actually do it and get successful filament, you're not gonna be able to do it at home. And these printers are very picky about whether or not the filament is the proper diameter all the way through. People also ask, what is the best software? Well, it's the one that you take the time to learn how to use. That's all I can say about that. People always want to know too is, can we ask you more questions offline after the presentation? Yes, you can. You can email questions. You can follow us on Facebook and ask us questions there. Do we do custom work? Yes, we still do custom work. You need to contact us and see if it's something that we can or cannot do. And that is going to bring us to the end, because there's this last little piece here that says, what does your CatzPaw setup look like? Well, we're going to hold off for that because I understand that you have a cool little video on Mondays. So this is going to be sent out to you, a link to it, so that you can watch it on Monday. And that brings us pretty much to the end of our presentation. Again, we are NMRA Partnership Program members. Use that code there when you order from our website to receive a 10% discount. And we hope you enjoyed this, and we're also open for more questions and answers. Okay, well, I hope you enjoyed it. Like I said, I know a lot of information in a short period of time, and thank you for having me do the presentation.
Well, thanks a lot for your time today, Sherry. I know everybody enjoyed it, so we appreciate you coming online.
And be sure to watch Monday's video too.
We'll do it. Okay, that brings us to the end of today's meeting and Zoom presentation.